Welcome back. In the last video, we considered a linear programming question and we solved it graphically. We solved it by sketching the region and evaluating the value of the function at all of the corner regions. And what we found out is that for such a function, a linear function with a region made up of linear inequalities, the maximum would happen at one of the corners of the allowable region. All right, so now that we know this, our goal is to figure out a way of solving these problems using algebra instead of using graphics. All right, so our goal for this section, using the simplex method, the standard form, is to solve linear programming questions algebraically. All right, so here's how to set up the starting tableau that we'll call. So the first thing is you're going to transform each inequality into an equation by adding a slack variable. You're going to add S1 to the first inequality, S2 to the second, and so on. And then you're going to set up a system and you'll get an augmented matrix. The variable of your systems are going to be the variable of your linear programming plus your slack variables, one for each constraint, and you'll consider P as one of your variables as well, the function that you're trying to maximize. You're going to get one equation for each constraint. They were inequalities to start with, but since we are going to add those slack variables, we're going to have equality, and one equation for P. And for P, you're going to use that P is equal to AX plus BY, like we said earlier. And so I'm going to send everything to one side and get equals 0. All right, so I want you to have an idea of what those slack variables mean. So if you think of a constraint as coming from the availability of a resource, you have a limited number of people working for you, a limited number of material, whatever it is, then the value of the slack variable represents the amount left over of these resources. So if S1 is equal to 0, then the first resource is fully used. If it's equal to 10, that means you have 10 of it left in whatever unit you're using. All right, so let's do this for the same problem as we'd considered in example 8.1.1. So we wanted to maximize P equals 2x plus y, and we had these three constraints and the usual request that the variables be positive. All right, the first thing I was told to do is I was told to add a slack variable to each of the constraints. So my first constraint was y is less than 10. So that means y plus whatever is left over should be equal to 10. And as long as S1 is positive, then my inequality is respected. Same thing for the second one. I had x plus y is less than 15. And so I'm going to ask that x plus y plus S2 is equal to 15. And 4x plus y is 36. So I'm going to add that 4x plus y plus S3 is 36. All right, so we're transforming inequalities into equations, and as long as S1, S2, S3 are positive, if our equations are true, our inequalities will be true as well. All right, we're ready. So my first equation, let's build the matrix here. I'm going to start with x, y. I have 3 constraints, that means 3 slack variable, and I have P, I have my augmented matrix, and then I'll have the constants. All right, first equation, I want to put y plus S1 equals 10. And so no x, y, 1 S1 is 10. Our second constraint equation was x plus y plus S2 is 15. So x plus y plus S2 is 15. Third was 4x plus y plus S3 is 36. And so 4x plus y plus S3 is 36. And so those are all the constraints. We were told something else though, right? So we have one equation for each constraint, but we also have one equation for P that we're going to use. We're going to transform this way. So the P equation is going to come from the definition of P, which is right here. So we have P equals 2x plus y, and that means P minus 2x minus y is 0. That's going to be your final row. So minus 2x minus 1 plus P equals 0. And I like to put these two lines here to really tell me that the bottom row is different. The bottom row is the profit. It's the one I'm trying to maximize. And so I want to separate it like this. All right, so that's how you set up the initial Tableau of